For people that love science, this is Equinox, where we're striking the balance between the light and the dark. Episode 1, Out of Infinity, I hope. The episode has no sponsors, so if you're listening, sponsors, get right on it. My name is Joseph Darnell, and I'm joined by Dr. Robert Carter. Hello, Rob.
Hello, Joe.
Yes, we've been discussing a new podcast for many weeks now.
Yeah.
I've been observing what you're doing on YouTube. You've been observing what I've been doing in podcasting, where we have our day jobs. And we got to talking about this, and it just seemed like a really good idea.
I mean, think of the things we can do and talk about, and the horizons are infinite.
You know, that was part of the idea behind the title. I'm not entirely sure what the journey was, that the creative journey we took to get to this title, but I loved it.
But when we came up with it, it's like all the bells rang. It's like, oh, that's a great title. Let's make something of it.
Well, I love the word, and it's really hard to find a good podcast title that isn't already in use.
Yeah.
But you know, from trying to come up with a title for your own YouTube channel, I would suppose.
That was hard.
Now, having said that, I don't want to get ahead of myself because we know the story, the backstory to the show and its origins, but we need to back up and explain to everyone and ourselves what we're going to talk about on Equinox. So, Rob, you have ideas, I have ideas. So what is your intentions with our new science podcast?
Well, as a Christian and as a scientist and as someone who's a total nerd and likes all sorts of different fields and different subjects, I know we got lots of questions. And honestly, I just love exploring knowledge. You know, what do we know? How do we know it? How far can we go in some field or something like that? I mean, I'm hoping we're going to talk about history and genetics and astronomy and geography and a lot of Bible in here. I mean, we're going to throw in all sorts of things into the mixer and see what comes out.
Now, a lot of the time, you'll find science podcasts that have a very particular bent.
Yes.
They're very mainstream, they're very culturally aware, and they don't want to offend anybody, or maybe they do want to offend some people because they have their biases, and we have ours too, wouldn't you say?
Yeah, but I'm not the type of person who likes to throw people under the bus. I mean, I try to be polite. I don't like
science experiments with buses and people.
Yeah, no. I don't subscribe to a lot of aspects of political correctness, but I tend to be politically correct in my speech. Just to be
makes sense,
polite and to not cause offense. In most cases, there are sometimes where I simply won't do it.
So you'd call that like a professional and civil courtesy.
Yeah.
Yeah, and I totally espouse to that as well. We're not going to rant and rave on this kind of podcast. We are enthusiasts that want to discuss our enthusiasm for science.
Absolutely.
And keep the politics out of it as much as possible.
Yeah.
Inevitably, because we work for a nonprofit Christian organization, and I have 10 plus years of experience in ministry, and you have more than that, I think we're going to be very mindful of our worldview that we bring to this. So a lot of people would call this their mindset, and we just can't help it because
it's going to ooze out of everything we do. Yes.
Yeah.
But when we get to questions about like races and racism, we're going to use culturally appropriate phrases.
Yeah. Well, and we have a lot of interesting details to point out to people that don't come from our point of view.
That's right.
But they are available if you go looking for them.
Yes. Okay.
So we were going to make a lot of perspective accessible to people who maybe have never heard our point of view as it concerns science subjects. And what kind of science are we going to talk about? Are we just going to talk about meteorology and biology?
No, we can talk about all sorts of things. In fact, one of my favorite
Meteorology isn't even science, is it?
I don't know about geology, but anyway. One of my favorite things is the history of science. And history of science coming out of Christian thinking and how the medieval people and the early modern people figured out how everything works and how they're exploring the universe and chemistry and astronomy, the things that they were challenged with and how they thought through things and figured out things like, hey, the earth moves.
Yes.
I mean, that was centuries it took people to determine that. It was a lot of work by a lot of people. And there's some scriptural challenges that came out of that. And there's a lot of debate that came out of it. And so we're going to address a lot of urban myths.
Yeah.
Like, Galileo was sanctioned by the Inquisition because he thought the earth was round. No, it was because he was a jerk. Or that Columbus was telling the church scholars of the day that the earth was round and they thought it was flat. No, that's not true. In fact, they knew how big the earth was, and Columbus was the one who was wrong. His earth was too small. He would have died. But he ran into this thing called North America. And so we have this whole history to it. Anyway.
So then for our listeners, and well, actually for our sakes as well, because this is episode 1, we're still oiling the cogs and what have you. Do you want to give a little bit about yourself?
Only if I can ask you afterwards. Let's interview each other. How's that?
Okay. Yeah,
All right.
But age before beauty.
All right, of course. So ask me a question and I'll try my best to answer it, Mr. Interviewer.
Okay. Who is Dr. Robert Carter?
Rob Carter is a scientist. I grew up in rural New York State. I went to Georgia Tech for my undergraduate, got a degree in just regular biology. I was a high school teacher for 4 years, so I taught physics and chemistry and AP biology, and I love that. And then I went to the University of Miami for my PhD and got a PhD in coral reef ecology, even though most of my work was in genetics. And ever since then, for the last 15 years or so, I've been studying human genetics, genetic engineering, and all sorts of fun things like that.
So then did your interest in science begin with education? Did you start this journey in high school or in college itself?
No, it was in high school. I was clearly cut out to be a nerd and a scientist from early years, and I knew it. I always wanted to be an astronaut. In fact, I wanted to be this first man on Mars. I didn't realize how long it would take us to get to Mars, so I'm still a little bit disappointed my life didn't work out that way, but
Well, you could still do it, but I don't recommend it now.
A little tough now, yeah.
So then what do you want to be known for? What is the legacy you want to leave behind?
Well, I'm not actually particularly interested in being known for anything, but I guess the legacy I want to leave behind is I want to encourage Christians in their walk, and I want to challenge non-Christians in their beliefs, and I want to leave the world with a better understanding of the Bible than they had when I came in. That sounds a little arrogant to say it that way, but there aren't many Christians in the world of science.
Yeah.
And there aren't many scientists out on the speaking circuit or on the article writing circuit trying to blend these two ideas together without compromising Scripture. And so I'm hoping that over time that we're building a better and more robust model specifically of human genetics, how we go from Adam and Eve to people today. That's my big thing. That's the thing I'm most interested in. And I think we are working on it. I think we're making tremendous strides.
That's going to be a very big subject, probably discussed in several episodes of the series.
Yeah, because there's so many different aspects of it, yeah.
So then outside of this podcast, what are you working on these days?
So my main employer is Creation Ministries International. Creation.com is our website. I've been employed by them for 13 or 14 years now. So I'm actively researching and writing and talking about various aspects of the Bible and science. My main focus is in genetics, but I keep getting pulled away to side articles.
Yeah, you've published a lot of articles and co-authored a lot of articles.
Yeah. In fact, I like co-authoring articles more than anything. I get more done and it gets faster and I get better ideas when I'm working with somebody else.
But you've also worked on a lot of field research projects with others as well. You are a collaborative person.
Yeah, well, my field research in marine biology and then genetics, just collaborating with other scholars on genetics is amazing and fun, especially the Christians who actually believe the Bible is real. But I have another side project I've been working on. I'm working on really hard. It's called Biblical Genetics. It's a YouTube show and a podcast. I haven't actually launched it yet, but I have filmed 20 episodes.
You're perfect for this, actually. You've already been on several documentary films, and you do an excellent job now for many years. I remember looking at one of the parts you're in for a film about Charles Darwin many years ago. You were much younger then.
Darwin, the Voyage That Shook the World. That was a fun project.
Yes, it's one of my favorite, the subject of Charles Darwin. I've seen it more than once, and I've shared it with my family. I think it's really good. And y'all went to the Galapagos Islands for that.
Yeah, that was a treat.
But you were much younger then. And I just got to tell you, I think that your presence on camera, you would do much better today than you would do back then.
I think you're probably right. That was my first foray into filmmaking, and I didn't have any control over anything. I just said, Carter, stand there and say this.
Yeah.
And I tried, and yeah, it was interesting.
Nowadays, you just look like the right version of yourself. You've got a full beard.
And it's all gray now, too.
Glasses look good. and you look like the science man on the field.
Yeah, back then I didn't have a beard because it was starting to come in patchy gray and it was a little embarrassing. But after I turned gray, I'm like, I don't care anymore.
Yeah,
I get this nice scientist beard now.
Right. See, back then, you would not have been in a Steven Spielberg movie about dinosaurs or anything scientific.
I'm not that old.
But I can see you as a bit part in some science-related science fiction subject in a film today.
I go for it.
Then you're working on the YouTube series, and how's it coming along?
It's coming along great. I mean, I am so much enjoying doing it. And what I'm doing is I'm actually piggybacking on all the traveling I'm doing for CMI. So I've been able to film episodes in Colorado, in Arizona, at Niagara Falls, standing on a frozen lake in Maine, in the Florida Keys, on Appalachian Trail. And that's just because they keep sending me all over the country. And, if I got an afternoon free, I'm going to go walk somewhere and do 20 minutes of filming and on some subject, viruses or genetic complexity or natural selection or something that has something to do with genetics. All right, so that's enough about me. Listeners don't want to just hear me prattle on and on and on, but my bio is on creation.com if they're interested.
Yeah, and they can find all of your articles there. We'll make sure that there's links to this stuff in the show notes.
All right, so enough about me. Tell us about yourself. Where do you come from? You have a very different background than me, but we have a lot of common interests.
Yeah, but I don't have the education that Rob has. I'm not a man of science, but I am enthusiastic about many subjects. So in the past, I have produced many podcasts. I'm a video producer for the same ministry at the moment that Dr. Carter works at.
And you did a great job on the Genesis Academy, by the way.
Well,
I know
thank
that
you.
was full-time for, 2 years?
Yes, roughly, and it was a rough journey, but making a bunch of scientists look good on camera, let me tell you, friends.
Herding cats.
Not everybody is cut out for this YouTube life. It does look pretty good now after the fact, and we've got a lot of positive feedback. So if you're one of those that has seen the series, thank you very much. The work I've done over the years, though, I've been in video production, graphic design, produced podcast. Recently, I have gotten into audiobook narration, and I love the arts.
I love listening to you read one of my articles. It's like, oh, that's how it's supposed to sound when it's phrased as if someone's reading it from scratch, not the way I have it in my head. I really enjoy it.
Yes, this is ladies and gentlemen, this is my audio podcast narration voice. No, I'm kidding. What Rob is referring to is here at CMI, we've started a few podcasts in 2019, and one of them is an article podcast where I'm just reading one of the articles twice a week. And the website's been going on now the articles have been published now for roughly 40 years, so there's a lot in the archive. And a lot of them are very timeless subjects, so it's really good material. If you're interested, you don't have enough time to read, then you've got an article podcast for you. And again, if you're interested in that show, a link will be in the description of this one. But I've been really interested in doing some more podcasting again outside of my regular work, our day job. And this is not a production by the ministry. This is not something that they're going to necessarily refer to at the website. And we're not going to talk about this in our public speaking engagements and the like.
Yeah, I wouldn't expect any CMI referral to us, but we're free to refer to things we love to do and all of our prior work. So we'll constantly be linking back there.
So this is not going to be officially a part of the ministry, and we're going to just talk about the science subjects that really interest us. This is an enthusiasts podcast.
Yeah, absolutely. And is this the appropriate time to throw in that disclaimer? The views represented on the show are not the views of the employer or anything like that.
Yeah, exactly.
All right, so we just did whatever that was. You just heard me say, that.
You know what it means, folks. Yeah. So, Rob, I think we're ready to get into the first subject of what a regular episode of Equinox might sound
Hopping up and down with excitement.
I'm giddy with excitement because I don't know what Rob is going to talk about.
You do. You know the topic. You get the outline.
I have the rough idea of what this stuff is, but I haven't been in school for 16 years, so I'm a little rusty on science. Dr. Carter, can you introduce our subject for today?
The subject of today is Isaac Newton's theory of gravity. It is the most profound engine of scientific predictions in human history.
Wow.
A simple observation has led to more results of more experiments than anything else ever done.
So we have thousands of years of human history before Sir Isaac Newton and the discovery of the theory of gravity. Mm-hmm. And for the most part, this is the foundation of modern science.
In fact, Newton, many people have called him the greatest scientist that ever lived. And I would say that's almost certainly true. but almost all of his great science was done in his 20s.
How has this related to your fields of science in the broad scheme of things? Like, would you say that he would be one of your science heroes?
No, absolutely, yeah. He gives us a way to think biblically, because he was a theologian. He wrote a lot more about theology than he did about science. But he also gives us a way to apply the natural world and to scriptures. I mean, he's approaching the natural world like it operates like a mechanism or a clock, because he thought the clockmaker made it. He didn't think it evolved. He thought, that very hand of God is infused into creation. And if God is a constant God, then the universe should be constant. If God is a God of law, then the universe should operate according to law. So his theology is directly being applied to his science. And what he did was he took the laws of planetary motion that Kepler figured out. Kepler figured out, how the planets orbit, and the fact that their orbits were not circles, they were ellipses. And he said, oh, that's because of this thing called gravity. And he was able to explain it. Before that, they didn't have an explanation. The scientists were just descriptive. I mean, for hundreds of years, a lot of cathedrals in Europe had a hole in the roof, and the sun would project on the floor of the cathedral. And the astronomers were going there all year long and doing all these measurements of the sun. I mean, for hundreds of years, they had all this data. And then these guys, Kepler and people like that, up on a rooftop with a board and a string, essentially, measuring the angles to all these stars and all the planets constantly over years and years and years, and all this data accumulated. And Newton said, I can explain that. Oh, really, Mr. Newton? You can explain all these centuries of scientific accumulations of data? Yep, I can. And he said this: everything in the universe attracts everything else in the universe. And here's the formula.
Wow.
Very simple formula, and boom. And this was so profound. Let me give my favorite scientific anecdote, I think, anywhere in the world of science. They're tracking the orbit of Jupiter and Saturn and Venus. And
In Sir Isaac Newton's day.
Yes, in Newton's day. And my very educated mother,
Who was not alive at the time.
that's right, just Jupiter, serves Saturn, us, Uranus. You can't really see Uranus.
No, of course. So from the night sky,
Yeah, you can't really see it. But what they did is, as they're plotting the positions of Jupiter and Saturn, they said, but something's wrong. Something's wrong. There's another planet, an invisible planet. And they did all this calculation, said, it's right here. And they found Uranus. And it's so a predictive engine here. We have this idea that everything's attracted to everything else. If that's true, that wobble in the planet should be because there's another planet.
even at vast distances in the solar system.
Yeah. And then Uranus had gone less than 3/4 of the way around its orbit. It takes a long time for it to orbit because it's so far out. And they said, something's wrong. There's another planet. Oh. And they used the trajectory or the orbit of an invisible planet to find another planet. What happened was, in fact, the British...
So what was the order? They had Jupiter and Saturn.
Yep.
From having their orbits around Earth, they figure out Uranus.
Yes.
Then by following Uranus, they understand there has to be
Another one. And the British missed it, but a German astronomer wrote a letter to the Berlin Observatory. He said, point your telescope there. And when they got the letter, that night, they discovered Neptune.
Wow.
So this is this predictive engine in science, and Newton is the epitome. His gravitational theory explains everything that happens in the solar system. It explains our rockets, it explains why there's a really cool application of this. We have a satellite or a spacecraft parked between the Earth and the sun.
Yeah. Okay, so this is one of the many, and this is taking pictures.
Yeah, and once an hour, it takes a high-def picture of the Earth. And because between the Earth and the sun, the Earth is always in full, and it sends the data back to us.
So what is the name of the satellite?
It's called the Discover satellite, and is parked in what's called the Lagrange point. It's a balance point between the Earth's gravity and the sun's gravity.
So this is not the Hubble Space Telescope, which we do know a lot more about, but this one is taking pictures as well of Earth.
But it's far away.
Yeah.
It's not orbiting the Earth, it's orbiting the sun. Oh. But it's close enough to the Earth that the gravity is balanced between the sun and the Earth, and it's just sitting there. They can use little adjustments every once in a while because, Jupiter flies by and it kind of messes up the orbit a little bit. But it's basically parked, and once an hour takes a high-def picture of the Earth and sends it back. It's really amazing. And you can watch videos of like the moon photobombing the Discover satellite because the moon just happened to go in front of the Earth at one point in time.
I love those pictures. I've seen them when you talked about them in a couple of videos for the ministry, and they're incredible. Seeing the backside of the moon, right? It's not even the vantage point that we ordinarily see from the ground.
The wrong side of the moon.
Yeah. Well, when I see the backside of the moon, I think it's Mercury.
They look a lot the same, and they're almost the same size, or similar size anyway.
Is Mercury gray as well?
Yeah.
I just assumed it was like the color of Mercury, whatever that is.
Yeah. I wrote a short story once about the first manned mission to Mercury, and they landed on the cold side, but Mercury orbits very slowly. And so they had like 88 days to drill a hole and sample the inside, and on the way out, their spaceship broke. And so what did they do? They ran around Mercury.
As you do.
They had 100 something days to get around, to get back to their starting point, because a new crew was coming in to rescue them.
Oh,
it's a short story. Everyone dies in a short story. You know how that goes. But anyway,
okay.
Yeah.
Okay, so we have the Discover satellite, and nobody's run around that one yet.
Nope. There's another really, really amazing application. NASA is planning on going back to the moon, finally. And they're working out how to do it. They've got, they planned this many missions before we have a crewed mission. We have this kind of robotic presence on the moon because they want a permanent moon presence. But in order to do that, what they're going to do is they're going to have a transfer vehicle orbiting the moon in a really, really, really complex pattern. It's beautiful when you look at the math of the ellipses going around the moon, small and big and small and big.
Really?
And it's not orbiting around the equator. They're orbiting north to south.
And why is that?
Well, because they can access the whole moon.
Oh, wow.
For the Apollo missions, they all orbited the equator, which means you can only land pretty much at the equator.
So if it's making a ring around the moon from top to bottom, is it slowly changing the degrees of rotation so that it kind of covers all the territory?
Pretty much.
Wow.
But if you see the video of it's just elegance. Mathematically, it's beautiful. It's just a cool application of gravity theory because once again, it's the greatest engine of scientific prediction in human history.
So even something as simple as that makes a world of difference to the science and engineering going on for this moon mission.
Absolutely, and it goes straight back to Newton.
I think one of the more fascinating things to me about science is how exact the theories that are good remain. They're tried and true, and they just don't change. Like a lot of our culture, even the things I listen to in other podcasts, there's a lot of theories tossed around in culture. They are
evolutionary theory
changing.
would be one of those.
Yeah,
It's not very mathematical.
right. Well, there's got to be a whole episode or 2 or 3 or 4.
More than that probably, yeah.
Yeah.
But gravity is entirely mathematical. It's a simple formula, and it explains everything. Until you get to really, really fast speeds and really high gravity. Then Einstein comes in.
All right, so I didn't mean to derail you.
Oh, that's okay.
But I am thinking about the theories of science, how if it's a good theory, it is just undeniable fact, and it goes with us for a long time to come.
Yes.
Basically should go indefinitely. Something like the theory of gravity by Sir Isaac Newton should be held in high esteem for thousands of years to come.
I've seen no challenges to it. I'm not expecting it to be replaced. Other theories can be replaced because, science is science, and probably half of what we think we know is wrong. We just haven't figured out what was wrong yet. And
if there's anything that is discovered like that during the series, we're going to talk about that on this podcast.
Yeah. All the fun new experiments. We'll probably have a ding, 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 newsflash around. We'll have to come up with some little thing. We'll wrinkle the papers and say, okay, just out of the Science magazine today is
little magazine. But we will definitely do that, Rob. We'll just take that soundbite of diddling from you.
All right.
We'll recycle and repurpose it. I'm a podcaster. I can do this sort of thing in editing.
So another thing that's really interesting is that any large body in the solar system is basically a sphere.
Yeah. Oh, you mean so anything larger than asteroids becomes spherical, like the moons, the many, many moons around all the planets of the solar system and beyond.
Most of the moons. Some of them are too small. Like Deimos and Phobos around Mars are kind of potato-shaped. They're not big enough to collapse into a sphere. But some of the asteroids, like Ceres,
Are large enough to...
be a sphere or pretty close to a sphere. But Galileo, looking through his telescope, noticed that Jupiter was not round. It's squished north to south. It's wider on the equator than it is north to south.
Oh, of course. Well,
Because it's spinning so fast.
Exactly.
And he didn't know why.
Well, hold that thought. You have to say that for an audience that's blind. They don't see what you did with your fingers.
Oh, well, okay. How do we describe to people who are just listening what I just did with my fingers?
Okay, well, I have an idea. So when you say that it's like a sphere and that it's a little squished, what you mean is what exactly? I know and Dr. Carter knows, but
Take a water balloon, a round water balloon, and set it on a table.
Oh, yeah.
It'll blob out on the sides, and it'll become less tall, but it'll become wider.
It bulges in the middle.
Yeah, exactly. It bulges around the whole middle. That's what Jupiter does.
And I'm assuming it's doing that just because the speed at the equator is faster than the top and bottom, where it's not moving relatively the same speed.
Jupiter is rotating so quickly
Yeah.
that the things at the equator are literally flung outwards. And it's enough of a distortion that Galileo could see it with his old-timey, cruddy telescope that's nothing like the telescopes we have today. But he didn't know why. Newton gives us an answer why. Because gravity wants, I hate that word wants. We say it a lot in science, just a shorthand for naturally. But if you take a bunch of stuff, it's all going to collect. It's all going to be pulled toward the center of mass. And so Jupiter is being forced into a sphere, except it's rotating so fast it blobs out on the edges around the equator.
Yeah, if you think about galaxies, the same thing is happening, right? They're all spherical. They usually come out in roughly the shape of a disk. And
if they weren't spinning, they wouldn't be a disk.
Yeah.
Yeah, they'd be a blob of stars.
And that is why CDs and records are the same shape, right? Oh, no. That's not how it
No,
sounds.
I think that's a little bit, that's a practical matters.
Oh, right.
Yeah, sorry. Okay, but we can apply the same thought to the Earth. And all sorts of weird things happen. Like the Earth is less tall than it is wide. For the same reason, it's spinning.
Right, of course. But how much? Are we talking about a mile or are we talking less than a mile?
Well, it's enough that Mount Chimborazo in Ecuador is further away from the center of the Earth than Mount Everest.
Wow.
So Mount Everest is higher above sea level.
Yes.
But because the Earth is bulged and Chimborazo is right near the equator.
That's like the shorter kid than the tallest kid on the basketball team gets to be called the tallest kid because he's got
on a
thicker
chair
shoes.
Or something. Yeah, thicker shoes or something. Yeah, exactly. So all sorts of, and in fact, you weigh less in the equator than you do on the North Pole.
Of course you do.
Well, but there's two reasons.
You're
One
being
is
flung right off a little bit.
One is that you're further away from the center, and the second is that you're being flung away. Now, it's only a few ounces per person, but it's measurable. We can absolutely measure this and go all around the world doing gravity measurements. And it's amazing, amazing science.
Would you feel any different depending on where you were and how the gravity was affecting you in those different places? If the temperature could be exactly the same and you could use a transporting portal to just jump through and pop out on the other side in another location with a different level of gravity, would you feel any different?
No, you lose and gain more weight than that per day by eating and drinking and the other end of eating and drinking.
Oh, whoa.
So you wouldn't personally notice it.
So would you notice the difference if you popped through the portal onto the surface of the moon?
Oh, absolutely.
You would feel different. Would you feel lighter, like you just...
If the elevator cable broke and you started falling and accelerating, there's probably some air resistance and maybe the wheels are... So you're not falling at absolutely as fast as you fall if you just jumped out a window. That's what it would be like to be on the moon.
So the elevator was just falling a little bit faster than you are.
Yeah.
And you start to notice that your impression
weigh
on the
as
floor
much.
is not the same.
That's right. You don't weigh as much and you notice you're accelerating downwards and it's rather scary. Well, that's what it's like to be on the moon. You don't fall towards the center as fast. You don't accelerate as fast. Gravity is less.
This reminds me of another discussion that I actually overheard you having here at the office. Got to bring it up because this was really weird.
Hey, which one? Because we have a lot of really fun and weird discussions, especially around the lunch table. I love going to lunch here. Anyway.
Yeah. Well, I'm usually the silent one at the lunch table listening to all these brainiacs and nerds.
I can own that.
I'm enjoying the discussion, mind you. I'm just not able to keep up with it. You do think faster than I do. The one that I remember was about falling through the center of the Earth and the role that gravity plays, and it got really weird. Can you explain how this would have, how the orbit of the Earth and the rotation of the Earth plays into what it would take for a object or a person to just simply fall to the center of the Earth?
Well, imagine the Earth isn't spinning first. And you dug a hole right through the Earth and you went down on a ladder and you stood or let go at the absolute center of the Earth. There would be no gravity.
So you couldn't fall up.
You wouldn't be able to get up at all because there's no falling. There's no gravity at the center of the Earth because all of the Earth is outside of you. All the Earth is pulling you outwards in equal proportions.
Would you be able to move? I mean, you wouldn't be able to stand. And
it'd be like you'd be in space. You'd be weightless.
Yeah. Okay.
That's the first weird thing.
Yeah.
Second weird thing is because the Earth is spinning, you can't dig a straight hole.
All right. Okay. So if for a visual,
from north to south, from the North Pole to the South Pole, you could, I think, dig a straight hole and jump in the hole and you come out of the South Pole. And just literally, you could just step onto the surface at the South Pole.
All right. So is it at all like traveling in a car and you toss a ball up in the car while you're going down the freeway? The ball travels with the car and it goes up and it comes right back into your hand.
Yes, except when we're talking about rotation, we're talking about an acceleration.
So as you're falling, it's not like the ball that goes right back.
It's like your dad stomps on the accelerator, you throw the ball up and it whacks you in the head.
Yeah, so the speed at which it was traveling is not the same once it leaves the hand.
That's right. Because the Earth is spinning, you have to dig a very strange shaped tunnel.
So if it was possible to dig the tunnel all the way miles and miles down to the core of the Earth,
yeah,
it couldn't be straight to fall to the center of the Earth.
Nope. In fact, you can...
If you were to do that, if you were to dig it straight, would you eventually hit the wall of the hole and start like scraping as you rolled down it?
Oh yeah, you'd be obliterated.
It'd be like falling down a cliff that you start rolling down.
It's worse than that. Because on the equator, on the equator, the Earth's about, in round numbers, about 24,000 miles in circumference. And I use miles, not kilometers, even though I'm a scientist, supposed to use kilometers. I do that because there's 24 hours in a day.
And there's 24 miles to the center of the core.
No. The Earth is rotating about 1,000 miles an hour at the equator.
Oh, okay.
But it's rotating at essentially 0 miles an hour at the center. So you're moving 1,000 miles an hour on the edge, and you jump in a straight shaft that's moving at no miles an hour at the bottom. You're going to hit the side, and you're going to go and be obliterated. It'd be really messy.
So if you're going to fall through the Earth, or any planet that is, as long as it's not gassy, then it has to have a curve to it. It has to be a trail, has to be winding to the center. It has to, sort of like if you were throwing a boomerang, it would have to be a hole that a boomerang would be able to traverse through.
It'd be really hard to actually make that hole. Another thing you can do, though, is you can make a curvy hole that comes back to the surface again without going through the center of the Earth.
Do what now?
You can fall into the Earth, but it's spinning,
yes,
and you end up falling upwards again without actually getting to the middle.
Oh, what?
Yeah, you just kind of miss the middle and you curve and pop up somewhere else. There's all sorts of weird math in here.
It depends on where you are.
Yeah, it depends on where you are.
How far you are from the equator. I was just assuming our hole was on the equator somewhere.
Well, that's what most people assume, but what if it's in...
What if it's not?
Senegal or Washington, D.C. or... Well, that is a hole. Never mind.
For all of the
politics. No politics on the show.
Well, then for all of our gravity nerds out there, get on this and start drawing some lines to the center of the Earth, but from different vantage points on the planet. Let us know what you come up with.
Yeah, that's a fun conversation.
Okay, so then we have the concept of gravity, and it's been running as long as time, and it goes off into the future. What does this mean for science in the future?
Well, gravity's pretty much settled, but it's this way of thinking that has changed science. The idea that there's not pixies out in the garden who are running inside to my laboratory at night and rearranging my test tube. Or there's no Zeus who hates me on top of a mountaintop, throwing lightning bolts down, trying to kill my bacteria in my petri dish. The idea that I can trust the universe because God, the guy who created the universe, is trustable, has led to the development of all of our modern technology. I mean, science just building on itself and building on itself in this predictive engine sort of way. Drawing hypotheses, rejecting hypotheses, trusting that the universe is behaving consistently.
For good pretty much everywhere in the solar system.
Yeah. This is that way because God. It's the nature of God himself that helps us pursue science. And for me, as a Christian and as a scientist, that is really exciting. And then when I'm sure we're going to do a podcast on this, a lot of people struggle in science. There's all these formulas, all these letters in these formulas. Oh, what's this letter mean? What's that letter mean? But usually when you're looking at a letter, very often it's the initials of a Christian's name. Because the early modern scientists, by and large, believed the Bible. And their approach to science was logical because they thought God was logical. And they laid down the groundwork for everything we're able to use today. All of our amazing technology comes from these thinkers. And Isaac Newton was perhaps the greatest of these thinkers, at least among the greatest. And he gave us things that will forever influence the development of science, the way we think, and our lives today.
We actually came very near to naming the podcast in something in association with Sir Isaac Newton.
Yeah, we did.
We talked about plays in the word of gravity and plays in his name Newton.
But then Equinox came up, and it just sounded so cool.
Can we say that the show and the series is dedicated to Sir Isaac Newton? I like that idea.
Well, I like that idea too.
Awesome. So let it be.
I second it.
Yeah, and we'll have that somewhere on the website in this episode's description.
Okay, I like that. Now, some people are going to complain that he was a heretic.
Wait, what?
Yeah, because he wrote a lot about theology, and he wrote some things about the Trinity that some of the people today have some problems with. But I do not think he was a heretic. I think he was asking questions about the Trinity that I have asked, and I think he came down on the right side of the equation. Show notes again. I'm sure we'll have a link there. As far as science goes, the man is head and shoulders above anything I could even think of accomplishing.
What became of his descendants? Did any of them become scientists?
I don't know if he had any descendants.
Really?
I know I've read his bio many times, but I don't remember anymore.
So along the way, we have discussed a lot of things to do with gravity, the solar system, the orbits and the rotations, Sir Isaac Newton.
History of science.
Yeah, so this is spurred on a lot of little other subjects that are going to be turned into full-fledged episodes down the road.
And I'm sure as we get comments and questions, those are going to be used as fodder for more talking.
Oh, yeah. Well, see, that's the thing is this show's going to be a little bit more organic, I want to say, than some of my other podcasts. Like if I'm doing the article podcast, it actually has a script. It's the article, and I cannot deviate from it. But for something like this, we want to hear from our listeners. Any questions you have, we'll have a section of follow-up. If we have follow-up for something that we thought about that our audience didn't think to bring up in the last week, we will bring up our own follow-up for a previous episode. So you might want to go back and listen to the previous episode until you get to the very beginning, the origins of Equinox. But then we're also going to discuss maybe things that we will bring up in the future. So like right now, if there's anything that you, our listeners, want to hear about on the podcast, please let us know. Find us on Facebook or Twitter or by email, because we will definitely be able to explore subjects much more fully here in discussion than necessarily Rob can with his Facebook page, or maybe in a fairly rapid video on YouTube.
And it's not an appeal to our listeners, oh, please give us content so we can talk about. No, it's help guide our content, because you and I can sit and talk for days.
Well, this is a conversation, and I like to think that this is a conversation with the audience as well.
Yeah.
So some of the other subjects we have right now in the works, we got Geocentrism Debate.
Mm-hmm.
I didn't realize there was a debate. I just knew that the Earth is geocentric, right?
There is a very small debate.
Okay.
But again, it's the history of science that comes in, and which makes it such a fascinating discussion.
Awesome. Okay, then we also have the age of the Earth. which is not the same as geocentrism.
No.
And then we also have science versus the Bible, or should I just say the broad scheme of things, religion in general, because I would like to explore that.
We do a lot of that.
Then we've got future technology and what it means for Christianity.
Genetic engineering and what it means for the future of humanity.
Which is huge. If you listeners, if you're not aware of the things that Rob has explored at creation.com in the articles, we'll just whet your appetite. We're going to put a link to an article in there because that is earth-shattering stuff. We're going to get to as soon as we can on the show. So it'll be highly featured as Equinox goes forward. But, if you're listening to the show and you're wondering about what sort of science subjects that we might cover, you might be thinking about, actually just about anything. If you have questions about, we joked about meteorology earlier. If something about meteorology comes up, we're going to talk about it.
Oh, well, global warming is a meteorological question.
Exactly.
Okay, so we thought of something. All right.
Perfect. That's going to be high on our list. The history of science, technologies, various theories that have been proven or debunked, scientific innovations, past and future, practical sciences, things that people can apply to their everyday lives. We're going to talk about some practical sciences because I need to know how science can improve my everyday life, Rob. Like, I want to have a good night's sleep. I want to be fit as a fiddle and live to be 150 years old. And science can help me do that, right?
I don't want to be living to 150 if I'm not fit as a fiddle. But it has been estimated that the first person who's going to live to be 200 years old has already been born.
What? No, wait, what?
The first person.
Oh, Rob, hold it. Save that for the next episode.
Okay.
Or we're going to just leave you with that teaser. So, ladies and gentlemen, thank you so much for joining us for our new quest. If you enjoyed listening, be sure to subscribe. If you want links to anything that we have discussed, they're available in this episode's show notes, as we've said. Be sure to follow Dr. Carter's Facebook page. It's called Biblical Genetics. And you can reach me on Twitter. My handle is @JCSDarnell. So if you want to help us out in a big way, write us a little review and rate the show on Apple Podcasts or wherever else you may be able to write a review for the podcast. And until next time, goodbye, Rob.
Goodbye, Joe.